All right, in this video, we're going to be taking a look at cosine law. I'm going to do a very quick introduction to the cosine law. You can take a look at the notes that have been posted online, or you look at different websites to see where the law comes from. I'm going to just quickly go through that. But more importantly, it's how the formula is used and why it has to be used instead of the sine law. That's the more important aspect. So once again, this law will be used for triangles that are not right angled. So much like the development of the sine law that you saw in the previous video that's posted on my YouTube channel, this is just a development of the cosine law. So again, there's a non-right angled triangle here, and the idea is to make some sort of connection between the side lengths and the angle opposite. So in this case, there's going to be a connection between the side length C and angle C. So what's essentially happening is this height of the triangle is being drawn in here to be able to create new formulas using Pythagorean theorem. So Pythagorean theorem involves right angle triangles. So labeling the different parts allows us to substitute and replace certain things. So if A is the entire length of this bottom part of the triangle, then A take away this Y leaves us with X. And that's what is being substituted in here. So what that allows us to do is to create a new formula. So this is just expanding, just using distributive property and coming up with a new formula. But then there's a replacement that can be done in terms of triangle ADC. So using the other triangle now, this one up here, you can get a new formula for B squared. And what then happens is you can then do a little bit of substitution. So the y squared plus h squared can be replaced with b squared because of this Pythagorean relationship that's in the triangle. But if we're trying to relate lowercase c, which is side c, with angle c, we need to use a trigonometric ratio. So in this case, the cosine of c, capital C, has the y and the b associated with it. Now, why is that important? Well, see this letter here? It's y. I don't want that. I want this formula to be nothing but A, B's, and C's. Whether they're capital or lowercase, I don't care. But I don't want these little y's in here. So I want to be able to use all the information that's in the triangle. So the side lengths A, B, and C, and angle A, B, and C. Using this cosine ratio, multiplying both sides by B here gives me this formula there. Okay, so that's what's happening here, and then a little substitution. So get rid of the y in the formula and replace it. And lo and behold, after simplifying, the common format for the cosine law looks like this. Okay, so what this essentially allows you to do is solve for side lengths if you have the other two side lengths and the angle that is opposite that initial side length that you're trying to find. Okay, so that's how the formula is set up. So I'll demonstrate that with the diagram down here below. And you notice I got it color coded as well. So this version of the formula is relating the fact that, actually let's do it this way. If you're trying to find this side length here in the triangle, then you must have the angle opposite that side. Okay, so the side is opposite that angle and the angle is opposite the side. So notice lowercase c, capital C on either ends of the formula. The first part of the formula looks a lot like Pythagorean theorem, but then you have this minus 2ab cos c. So what you're going to need to be able to find c is you're going to need the other two side lengths and the angle that is formed between those two side lengths to be able to use this formula. Okay, now let's say you wanted to find this side right here, side B. Well, to use the cosine law, you would need the angle opposite. Okay, and take a look at the way the formula is set up. So again, very much like Pythagorean theorem. So if you're trying to find side A, then you need side B and C. And again, there's side B and C in the formula, but you need the angle that's opposite. So again, there's the connection between the side and the angle that's opposite that side. Now keep in mind, these are generic formulas. So it doesn't matter if the labeling is A, B, C, X, Y, Z, it's the pattern that's important. So it's a kind of a Pythagorean pattern at the beginning, and then minus 2 times the product of the two sides that you're given, followed by the cosine of the angle that is opposite that side. Now, obviously, with any formula, you can manipulate it depending on which pieces of the formula you have and which ones you don't have, and rearrange using inverse operations, but that's essentially it. So the same thing's true with side B here. So if you're trying to find, sorry, I think we already discussed that. I think I got a little confused between A there. So again, so with angle A being opposite side A, there's the formula there. And I believe earlier I was saying we were going to find B, but I did it in the wrong order. My apologies. All right, but anyways, that's the connection. So that in the formula, the angle that you're using on the end here has to be opposite the side length. So you'll see that in an example or two in a moment. Now, this formula also allows you to find the angle. So if you wanted a certain angle, but you had all the side lengths, then you could rearrange the formula by, again, using inverse operations. So subtracting the side lengths on that one side, followed by a division by this part, getting the cosine ratio by itself, and then to find the angle itself, much like we looked at before, it's a cos inverse. So you'd have to take whatever this quantity is, obviously change it to a decimal more than likely, and then find the cos inverse to find that angle. Okay, so let's see how this works in a couple of examples. So this first one here, you've got Ken's cell phone detects 2 transmission antennas. You might see these around the neighborhood. Funny looking antennas, often wonder what they're for. And many times they're for transmissions of data using your cell phone. So one is 7 kilometers away and the other one's 13 kilometers away. From his position, the 2 antennas appear to be separated by an angle of 80 degrees. You can kind of use your arm sort of to measure that out. How far apart to the nearest kilometer are the 2 antennas? So again, you don't have to get fancy with the diagram, but here's a diagram that fits the situation. So here is Ken, there's his cell phone, and there's the 2 towers, transmission towers. One's 7 kilometers away, the other one's 13 kilometers away. There's the angle between them, 80 degrees, okay? And it's asked, how far apart are they? Now, if you wanted to try and use the sine law, here's the difficulty you're going to have with the sine law. This ratio will have an unknown, and that's the x. This ratio with the sine law will also have an unknown because you don't have that angle. And this ratio with the sine law has another unknown as well. So much like in the previous questions with sine law, you have to have one of those ratios complete to be able to use the sine law and work it properly. You can't do that in this case. That's why the cosine law is important and useful to have in this case. You do have 2 side lengths and you have the angle between them. So you should be able to use cosine law to find the angle or the side length that's opposite. Now watch how this works. So again, let's go back to the formula just quickly here. So just using this last one here. So if I wanted to find a particular side length, I need the angle that is opposite, but I also need the side lengths that are creating that opposite angle. And I get a version of the formula that looks like that. So let's see what we have. We have an angle. I'm trying to find the side opposite, and I have the side lengths that are containing the angle. So let's see how this works. So if I'm trying to find x, I would start off with x squared. That's part of the formula. Again, the first part is kind of Pythagorean looking. So x squared, and then the 7 and the 13 are the other 2 side lengths. Okay, minus 2 times the 7 and the 13. Those are the 2 side lengths, and then cosine of the angle opposite. That's what this red is indicating. So I want the angle opposite the x, and that's the 80. So once you have all that set up, it's basically just using Bedmus very carefully to be able to find x, because that's what we're looking for. How far apart to the nearest kilometer are the 2 antennas, and that's what's the x representing in the diagram. Okay, so as long as you use Bedmus very carefully, do the multiplication and then the first, followed by the subtractions and the additions. That's what I'm showing you here in these steps. You get down to a value of x squared, and to find x, simply take the square root and get an approximate answer. Okay? So again, important, the most important step, much like sine law or any formula for that matter, set up the formula properly. And then from there, it's simply bedmus and calculator work. So it's not too bad. So that's the hardest part, getting a diagram, make sure it's accurate, read the information twice, and then come up with a formula and work with it. And that's essentially it. So we're going to take a look at another one here, just a slightly different wording though. Triangle has side lengths that measure 5, 6, and 10. Are any of the angles in this triangle equivalent to 30 degrees? Okay, so here we have just a reference triangle where all the side lengths are labeled in there. I decided to use A, B, and C just because. You could have used any letters you really like. And you're trying to find or determine if any of these angles are 30 degrees. Now, again, let's try sine law. Well, sine law is going to have incomplete ratios because you don't have any of the angles. So you can't use sine law. So earlier, I mentioned that there's a way of finding angles using cosine law. So let's take a look. So for the cosine law, I can set up a formula. Now you can use the formula I showed you previously. Let's just jump back to that real quick. So this one down at the bottom. Some students find this hard to remember though, right away. So I decided to just simply start with the cosine law as is the typical setup, as I've been mentioning with the Pythagorean setup, and then minus 2 times those two side lengths and the cosine angle, and then just use inverse operations. Okay, so it's your choice how you want to set this up. Textbooks and online questions will obviously have a variety of things. So if I'm trying to find angle A, so I want to see if angle A is 30 degrees. So I would need to use the side length opposite angle A. So opposite angle A is side length 10. So I'm going to set up that Pythagorean first part of the formula by using the side length. So 10 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cosine of A. And then using inverse operations, much like in that previous example from a few minutes ago, just finding angle A. So again, this is using bedmus in reverse, so inverse operations. All right. So we get angle A is 130 degrees. Okay, so that's using inverse operations. Following there. So that's obviously not 30 degrees. Now, here's the one thing you have to realize. As soon as you realize that one of the angles is 30 degrees here, so I'll just put that in. So now that we've determined that this angle up at the top is 30 degrees, then now we have some choices. Whoops, sorry, that should have been 130. So we still are looking to see if any of the other triangles or angles is 30 degrees. Now, we could do the same thing, use cosine law all over again. However, now that we have one of the side lengths complete, I could use sine law because I have a complete ratio here with A and the 10, and I can use it to find angle B using sine law. So this is now an instance where you can use sine law since we now have one of the angles in a complete ratio that we can work with. So as you can see, I've set that up here and got that listed for you. So sine of B would leave us with an angle that is 27 degrees, and that's also not 30 degrees. So we haven't ruled out that last angle yet, but again, the amount of work you're going to put into finding these angles is up to you. So we were forced to use cosine law to get angle A. You could have repeated the same process to find angle B, use cosine law, but I decided to use sine law just for a difference, okay? So it really doesn't matter. It might make things a little bit easier. So angle B is 27 degrees. Now, here's something else. So now that we have angle B is 27 degrees, we have 2 out of the 3 angles. So angle B is 27 degrees. This is 130. How can I find the third angle? Right, just simply subtract from 180. I don't need to use sine law or cosine law. Okay, so again, you have to think of these things that are possible when you're working with this. So after determining the final measurement, we've got none of the angles measure 30 degrees. And that was the goal for the question, was to determine if any of the angles are 30 degrees and justify, show all your work. Okay, so again, using the cosine law is something that is extremely important when necessary, but in some problems, once you've succeeded in solving part of the problem, it may be possible to use other mathematical techniques like sine law or some of the angles to answer various questions. Okay, so hopefully this video was helpful in understanding cosine law.